The National Electrical Code, or NEC, necessitates the implementation of metal-clad cable, known as MC cable, conduit, or other endorsed wiring techniques in concealed areas of commercial structures. This encompasses buildings used for religious assembly. The NEC mandates this heightened degree of safeguarding due to the possibility of concealed fires within commercial establishments. Romex, characterized as a non-metallic sheathed cable, exhibits greater susceptibility to damage and possesses the capacity to contribute to the propagation of fire if not appropriately installed and shielded. The pertinent NEC section is Article 300.22c, which states that in commercial and industrial occupancies type NN cable shall not be installed in concealed spaces such as walls, ceilings, or floors of buildings. For the interior with stud walls, an approved wiring method must be employed, such as MC cable, which is a metal-clad cable featuring a flexible metal jacket that affords supplementary defense against fire and physical harm. Conduit, representing a rigid or flexible pipe, serves to safeguard the wires from impairment. Surface raceway, denoting a raceway affixed to the wall surface, accommodates the wires. There exists an exception to the NEC stipulation that permits the utilization of Romex in concealed spaces of commercial edifices, contingent upon its installation within a listed cable tray, raceway, or alternative sanctioned enclosure. Nevertheless, this exception remains inapplicable to religious assembly buildings. Consequently, the building inspector is accurate in conveying that Romex cannot be implemented for the interior with stud walls within the religious assembly building. An endorsed wiring approach, encompassing MC cable, conduit, or surface raceway, must be adopted. Let's delve deeper into these wiring methods. Firstly, consider metal-clad cable or MC cable. This type of cable consists of conductors individually insulated and then encased in a flexible metallic sheath. The metal sheath provides a robust layer of protection against physical damage, such as impacts or abrasions, which is particularly important in commercial settings where there is often more activity and potential for accidents than in residential environments. The metallic sheath also offers a degree of fire resistance. Should a fire occur, the metal helps to contain the flames and prevent them from spreading as quickly as they might with non-metallic sheathed cables. This is a critical safety feature in commercial buildings, where fire could have devastating consequences due to the larger number of occupants and the potential for extensive property damage. MC cable is versatile and can be used in a variety of applications, including concealed wiring in walls and ceilings, as well as exposed runs where it is properly supported. It is suitable for both dry and damp locations, but not for wet locations unless specifically designed for that purpose. Installation of MC cable typically involves the use of specialized connectors and fittings that ensure a secure and grounded connection to electrical boxes and equipment. The metal sheath must be properly grounded to provide a path for fault current, which helps to prevent electrical shock hazards. Secondly, think about conduit. Conduit is a rigid or flexible tubing made of metal or plastic that is used to encase and protect electrical wires. There are several types of conduit available, each with its own characteristics and applications. Rigid metal conduit, or RMC, is a heavy-duty option made of galvanized steel or aluminum. It provides excellent protection against physical damage and is often used in exposed locations or where there is a risk of impact. Intermediate metal conduit, or IMC, is similar to RMC but is lighter in weight, making it easier to work with. Electrical metallic tubing, or IMT, is a thin-walled conduit made of steel or aluminum. It is lighter and more flexible than RMC or IMC and is typically used for concealed wiring in walls and ceilings. Flexible metal conduit, or FMC, is a flexible option that is used in situations where the conduit needs to bend around obstacles or where vibration is a concern. Liquid-tight flexible metal conduit, or LFMC, is a type of FMC that is covered with a waterproof plastic coating, making it suitable for use in wet locations. Conduit provides excellent protection against physical damage, fire, and moisture. It also helps to contain electrical arcs and sparks, reducing the risk of fire or explosion. The use of conduit allows for easy access to wires for maintenance or modifications. Wires can be pulled out of the conduit and replaced or added without having to tear into walls or ceilings. Conduit must be properly grounded to provide a path for fault current and prevent electrical shock hazards. The choice of conduit type depends on the specific application and the level of protection required. For example, RNC might be used in a manufacturing plant where there is a high risk of impact, while E&T might be used in an office building where the wiring is concealed in walls and ceilings. Thirdly, consider surface raceway. Surface raceway is a wiring system that is installed on the surface of walls or ceilings, rather than being concealed behind them. It consists of a channel or trough made of metal or plastic that is used to contain and protect electrical wires. Surface raceway is a versatile and cost-effective wiring solution for a variety of applications, including offices, schools, retail stores, and industrial buildings. It is particularly useful in situations where it is difficult or impossible to run wires through walls or ceilings, such as in older buildings or in buildings with concrete walls. Surface raceway is easy to install and modify, making it a good choice for renovations or additions. It can be easily cut to length and attached to walls or ceilings with screws or adhesives. Wires can be easily added or removed from the raceway as needed. Surface raceway provides a neat and organized appearance, concealing wires and cables and preventing them from becoming tangled or damaged. It is available in a variety of colors and finishes to match the decor of the building. Surface raceway provides a degree of protection against physical damage, fire, and moisture. However, it is not as robust as conduit and may not be suitable for use in areas where there is a high risk of impact. Surface raceway is typically made of metal or plastic. Metal raceway provides better protection against physical damage and fire, while plastic raceway is lighter and easier to work with. Choice of raceway material depends on the specific application and the level of protection required. There are several types of surface raceway available, including wire mold, which is a metal raceway system that is widely used in commercial and industrial buildings. Plastic raceway, which is a lightweight and cost-effective option for general-purpose wiring. Modular raceway, which is a flexible system that can be easily configured to meet specific wiring needs. In the context of religious or assembly buildings, the NEC prioritizes safety due to the potential for large gatherings of people. Choice of wiring method is crucial in ensuring the safety of occupants and preventing fire hazards. The prohibition of Romex in concealed spaces is a specific measure to mitigate the risk of fire spread, given its non-metallic composition and potential vulnerability to damage. The alternatives, such as MC cable, conduit, and surface raceway, offer enhanced protection against physical damage and fire, aligning with NEC's stringent safety standards for commercial buildings. When undertaking electrical work in a commercial building, particularly one used for religious assembly, it is essential to adhere to the NEC guidelines and consult with qualified electrical professionals to ensure compliance and safety. It is important to remember that electrical codes and regulations are subject to change, so it is always best to consult the latest edition of the NEC and local building codes before starting any electrical work. Furthermore, it is crucial to obtain the necessary permits and inspections to ensure that the electrical work is performed safely and in compliance with all applicable codes and regulations. The selection of appropriate wiring methods and materials is just one aspect of ensuring electrical safety in commercial buildings. Other important considerations include proper grounding, overcurrent protection, and the use of arc fault circuit interrupters, or FSIs, to prevent electrical fires. Grounding is a critical safety measure that provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock hazards. All electrical equipment and wiring must be properly grounded in accordance with the NEC. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices automatically interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. FSIs are specialized circuit breakers that are designed to detect arc faults, which are dangerous electrical arcs that can occur when wires become loose or damaged. A size quickly interrupts the flow of current when an arc fault is detected, preventing electrical fires. The NEC requires the use of a size in many areas of residential and commercial buildings, particularly in bedrooms and other areas where people may be sleeping. In addition to these specific safety measures, it is also important to follow general electrical safety practices, such as always turn off the power before working on electrical circuits. Use insulated tools and equipment. Never work on electrical circuits when you are wet or standing in water. Inspect electrical cords and equipment regularly for damage. Replace damaged cords and equipment immediately. Do not overload electrical circuits. Use extension cords sparingly and only for temporary purposes. Do not run extension cords under rugs or carpets. Keep electrical panels and outlets clear of obstructions. If you are not comfortable working on electrical circuits, hire a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. The NEC provides a comprehensive set of guidelines for electrical safety, and it is essential to follow these guidelines to ensure that electrical systems are installed and maintained safely. By adhering to the NEC and following safe electrical practices, you can help to prevent electrical accidents and ensure the safety of occupants in commercial buildings. It is paramount to engage licensed and experienced electrical contractors for all electrical installations and modifications. These professionals possess the knowledge and expertise to ensure that the work is performed in accordance with the NEC and local codes, minimizing the risk of electrical hazards. Regular inspections and maintenance of electrical systems are essential for identifying and addressing potential problems before they escalate into dangerous situations. Electrical panels, wiring, and equipment should be inspected periodically to ensure that they are in good condition and functioning properly. Any damaged or worn component should be replaced promptly. Over time, electrical connections can become loose, leading to overheating and potential fire hazards. It is important to periodically tighten electrical connections to ensure that they are secure and making good contact. Surge protectors are devices that protect electrical equipment from voltage spikes, which can damage sensitive electronic components. Surge protectors should be installed on all critical electrical circuits to protect computers, televisions, and other electronic devices. Emergency lighting systems provide illumination in the event of a power outage, allowing occupants to safely evacuate the building. Emergency lighting systems should be tested regularly to ensure that they are functioning properly. Fire alarm systems are designed to detect fires and alert occupants of the building. Fire alarm systems should be tested regularly to ensure that they are functioning properly and that occupants are familiar with the evacuation procedures. Electrical safety is a shared responsibility, and everyone can play a role in preventing an electrical accident. By following safe electrical practices and being aware of potential hazards, you can help to create a safer environment for yourself and others. In summary, when dealing with electrical installations in commercial buildings, particularly religious assembly buildings, understanding and adhering to the NEC is paramount. The code stipulations regarding wiring methods, such as the prohibition of Romex in concealed spaces, are in place to ensure the safety of occupants and prevent fire hazards. Alternatives like MC cable, conduit, and surface raceway offer enhanced protection and align with the NEC stringent safety standards. Engaging licensed electrical contractors, conducting regular inspections, and implementing additional safety measures like grounding, overcurrent protection, and emphasize are crucial steps in maintaining electrical safety. By prioritizing electrical safety and following the NEC guidelines, you can help to create a safe and secure environment for all.